Hello guys, so I am telling you this is the topology and I am gonna do initial OSPF configuration here. So these are my loopback addresses up there, and this is my IP address that I am assigning to my routers. And same here, this is my loopback address, this is my IP address. So this is the topology I took. 2621 routers, whereas I got a 3650 layer 3 switch, but I'm not going to use it as a router, I'm just going to use it as a switch. So initially what I did here is that I've done the initial configuration. As you can see, I have used a loopback address, this 1111 for router 1, and an interface that I have used for Ethernet 00. I assigned the IP address 192.168.1.1, and the rest is same. I did similar with other routers. So now I have to check the routing table, show IP route. So I only assigned the IPs to the connected interfaces and nothing else. So these are the only two connected interfaces, nothing else. This is loopback 0 and this is fast Ethernet 0. This is loopback 0 and this is fast Ethernet 0. Now I am going to start the OSPF, applying OSPF routing protocol on this and this topology. So first of all, we will go to global configuration mode. Then, as we do for the RIP or EIGRP, we write it IP router RIP. You can check same as router EIGRP, and similarly I'm going to apply router OSPF, and then I have to give a process ID. The process ID could be between 1 and 65,535. So for example, I select process ID 1, then I have to declare the networks that I am using on this router that I want to share with the other router. So there are the networks. This is one network and this is the other network. So I will write it like 1.1.1, and now I have to write my wildcard mask instead of the subnet mask here. And wildcard mask is exactly the opposite of the subnet mask. So I want to advertise this route as a whole, so I will write 255 255 255 and 255 because I want to advertise these bits completely. This is /32 network, and then I have to specify the area, which area I am using for this topology or this router. So this is a normal topology. Initially I'm using the area 0 because there is not a bigger network. I'm not dividing these routers into different networks. So initially this is area, but area you must specify. So the area that I can specify is between 0 to this big number, but as I'm using only one area, so I will specify 0. Okay, now I have advertised one network and I have to advertise other network. If you forget which networks did you already advertise, you can simply write a command here like show IP route, and sorry, not here, show IP route, and now you can see the connected networks here. So this was the network that I already advertised. Now this is the network that I must advertise right now. So I will go again, router OSPF 1, that was my process I initially used, and now I have to advertise this network here. So I will write network 192.168.1.0, and the wildcard mask for this will be, because I just want to use this octet, the last part, so I will write it like 0000 and 000 and 255, and area will be 0. And now I will come back and check my routing table. This is same because it is not getting any routes from the other networks. So my router is having only these two networks advertised. Now I have to go to next router so I can do the configuration. So initially you will see show IP route, and it also has only two. Let's go and configure the OSPF router OSPF1. Process will be same in the whole topology, so there is no change. Network 2.2.2 because this is the loopback address in area 0, and the second network that I have here is the same network, but the IP address for this router is changed. So I have to use this, and now you can see there is a neighbor relationship between the router 1. This is the loopback ID of the router 1. So there is a neighbor relationship that was gone from loading to full, and loading is done. Now these two are neighbors. So let me check now show IP route, and you can see there is an OSPF route, that is OSPF network actually, that it got from 192.168.1.1. This is the router, and they made successfully the neighborship. So you can see they can also ping each other. Now I will try to ping the loopback address of router 1. It ping. Now I will try to ping the IP address of the router 1, and they ping it. Now I will do the same thing from, obviously I can do it from the other side, like other router. I will try to ping the loopback address of router 2, and it's done. Now I have to do the same thing on router 3 and router 4. So let's do it. Okay, now I already know the networks of this, but for you I will just run the command show IP route, so you can easily know which IP addresses are here, which networks are actually here that I have to initialize, or that I have to advertise in this network. And I will go to router OSPF1 network 3.3.3.3, and the wildcard mask for this is that. Now the next network for this router is that, for this whole network is that this one, and 255 for the lost like the octet, so I can have the, okay, now you can see there is a neighborship relationship. Neighborship is done between the router 2 because this is the loopback ID of router 2, and between the router 1 and 3 because this is the loopback ID of router 1. And the neighborship gone from loading to full, loading done. Now I will try to ping router 1 first of all. This is the loopback address, and now I will try to ping the router 2, and that's done successfully. Now the left is router 1, sorry, router 4. So I will first check the networks that I have to advertise. These are the networks actually. 444 is the loopback address of this router, and 192.168.1.0 is the network of this router. So I will just try to run simple router OSPF and the process ID, and then the network that I have to advertise is 4444 and area 0. And now the next sorry, area 0, yeah, now it's done. Now we'll try to ping all the other networks, like from router 4 to router 1. This is good. From router 4 to router 2, and from router 4 to router 3 there is some problem. Okay, now it's done because the first is lost because of the ARP, and now it's done. I will ping again, and it will get the 100% result, and that is the 100% result, you can see. So now I will check the show IP route command. I will run it because I want to check what is my routing table telling that, okay, it has a neighborship between network 1, network 2, network 3, and these two are the connected networks. It's local. locally connected. And I will go and check the same thing on router 2. So show IP route, and it has the other three networks, 111, 222, and 444. I will go and check on router 1, show IP route, and it has, except itself, it has the other like 2, 3, and 4 networks, 2 network, 3 network, and 4 network it have. Okay, now there are some commands to check. Show IP OSPF 1. This one is the process, so it will show me all the ISP process OSPF processes. So I have written the process number, for example, show IP OSPF, and I put the question mark, and it shows me, first of all, you can check the processes, border routers, database, interfaces, neighbors. So I have to check the processes, like process 1, it showed me the process. So the ID for this process is on the local router is this, and it support LSAs and some other information, and whole time between the hello, it has some other like you can see a lot of information is here. So this area is backbone. That's what I said, because I always set the area. You can see up there the area was 0 whenever I set the area. My area, when I advertise my networks, my area was 0. So this is the backup area. Actually, when we are not using many area network, then we use only the backup area, that is area 0. And now I will check the neighbors. Okay, who are the neighbors of this router? Router 1 has a neighbor 2222, 3333, and 4444. These are the routers. Now there is an interesting thing. We can see who is the DR and who is the BDR. DR is actually designated router. That is the, you can say, the master of this network right now, and the BDR is the second master. So what does BDR do? It actually updates itself, and it tells the other routers in the topology whenever there is some change, that is going on in the topology. So when it feels like, okay, there is some change, it updates the other routers that this is a change, please update yourself as well. So what I have done here, I have run the command show IP OSPF neighbors. It shows you the neighbor and also tells you the state of the neighbors. Then this neighbor 2222 is now fully connected, and it is BDR. Okay, not the DR. Okay, this is the BDR. So this is DR other. So except the DR and BDR, all the routers are others. And okay, now check who is the DR, because there is no other router showing here which is named as DR. So it means my router is router 1 is the DR. Let me check from router 2 so I can get a clear idea. Show IP OSPF neighbor, and now you can see that here are the other three neighbors of this router, and 1111 has a state of full, it is fully connected, and it is DR, and the other 3 and 4 are BDR. Now let's do one thing, that okay, let's check first from the router 4 the same thing, and you will get to know that this router, which is not mentioned here, is actually the other router, because DR is here and BDR is also here, and there is one DR other, but there should be another DR other, which is the router itself. So it is not showing it the status of itself. It means it is the DR other. Now what I am gonna do is that, let's see if this DR goes down or it fails, so what happens, who will be the next DR and who will be the next BDR. Okay, so I will save the configuration and I will try to reboot it. You can save the configuration in two ways. WR is one way, like it is the shortest way, and the other way is that copy running configuration to startup configuration, and it asks you for confirmation, like confirm that you want to do it or not. I said enter, and this is okay. But if you don't want to have the confirmation, like the router should not ask you about the confirmation, then you can simply write WR and it will give you the right memory. Okay, so it will give you the simply like, okay, the memory is written RWR. Okay, now the data, all the data is saved. Now let me just reboot it. Sorry, this doesn't work. So I will just check what I can do for shutdown. Okay, reload, you can also use. Reload is a command that will perform a cold restart. It will just restart it and just confirm. Okay, now my router, as you can see from here, this link is down because this router is actually down. It is restarting. It takes a little bit time, and now press return to get started. Okay, now my router is started and I have to go first of all check my running configurations and if these are saved or not. Okay, my host name is the same as I saved and my IP address is the loopback is same and this. Okay, that means uh, my configuration that I have saved, I have done on this computer is saved. Okay, so let's check now. Show IP OSPF neighbor. Who is the neighbor? Who is my neighbor right now and who is uh, like DR and BDR. Okay, it tells me about only two neighbors and now okay, third neighbor also came here because it takes time. It takes time to get to know who are my neighbors. Uh, I will check again this command and now there are three neighbors. Okay, now first of all, the in the last like after restarting, before restarting this computer, this router actually, DR was this router itself, but now you can see the DR is changed. The second router, router 2, became the DR and the third router, like the fourth router, became the BDR. So whenever your DR is down, your topology make changes, your network make changes, because there must be a DR and there must be a BDR in any case. Okay, otherwise the things will not work. So when your BDR or DR, anything like it is down, they must select some other DR or BDR. Now, what is the criteria for uh, for making a DR or BDR? Okay, first of all, I will let you know that it when I made this router, I just configured this router first of all, and then I configured OSPF on this router. So automatically this router has become the DR. Okay, and then the next router that I configured was this router. So these both were selected. This became DR and that was the BDR. That's why they were showing, like you can see this router, which was BDR first, has become like the DR in the next process, because this was the BDR and this was the DR. No, there is no more DR. So BDR took its place, and now they check like, okay, which router actually is, sorry, I just split this is 3.3.3 and this is 4.4.4. So they check which router is actually the is suitable for the BDR from these two, because this was down and this became DR. No, they needed a BDR. So they have checked which router has the biggest IP address. So they check the loopback address and loopback address of this, because the loopback is preferred address. You can see here the loopback address is given. It is shown as the neighbor ID. So this loopback address is the bigger loopback address, like number 4 is bigger than the number 3. So this router was selected as the next BDR. Now I will let you know, like I will do something else. I will try to switch off this router. Okay, I will reboot this router and let's check who will be the next BDR. So what will happen, let me tell you that if this router is BDR right now and it is down, so the election will be done between these two routers, because this is now a DR and this is a BDR. No, there will be no more BDR, so the election will be done between these two routers, and they will check whose IP address is the bigger one. So whose neighbor ID is actually bigger one, because the neighbor ID automatically they selected as their loopback address, and which loopback address is the bigger one, 3 or 1. Okay, let's see. Let me just save the configuration. Okay, I sometime the packet tracer does some problems, so I prefer to save my configuration in both the ways, write memory and copy running configuration on the start of configuration. And now I will reload and I will confirm it. Okay, now this router is no more, this router is down, and I will check. No, we have to check the election is already done between these two, and they have automatically selected a BDR from these two. Now we just need to confirm which is the DR and which is the BDR. Actually DR will not change because DR is still this one until this goes down and they will select another BDR. So I will just check the IP route, so I can check my other connections, and unfortunately this will take time because the link is down and OSPF takes some time to get to know who are my neighbors. Now this link is up, and I will check again show IP route, and I'm still unable because there are now you can see OSPF started, and in the first few seconds they checked like they got two neighbors, get two neighbors, like okay 2 and 3, and it's still getting far one more, waiting for one more neighbor. Show IP route, let's check, and there are three networks which I have initialized and advertised in this. Show IP OSPF neighbor. Okay, it got all the other neighbors, so these are the three neighbors. Now you can see that initially this router was a BDR, but since it is down, the election between these two was done, and now let's just check who is the DR and who is the BDR. So you can see 4 is not here because 4 is the local router, and but still there is a BDR showing us in the neighborhood somewhere on 3, and there is the DR that is not changed because the DR was this router. I told you DR will not change, but the BDR is changed. So it checked the election. In the election they check like which router has the biggest neighbor IDs. So the loopback address of this router was big, so it is selected as the BDR. That's all the election process, folks, and you can see the initial um, configuration of OSPF. So this is the initial configuration of OSPF. You just need to advertise your connected networks inside, and that's how it works. I hope you like the video. If you like it, please press the like button and try to subscribe my channel. I am not uploading a lot of videos, but if I get a positive response then I will be uploading. Thanks a lot. Bye.